E170 Flight Management System and Auto Throttle. Normal operating conditions. The FMS on the E170 is designed to enhance flight efficiency and safety by automating various navigations and performance tasks. It integrates data from multiple sources, including GPS, initial reference system, and air data computers, to calculate optimal flight paths. The FMS allows for pre-programmed routes, enabling pilots to manage waypoints, altitudes, and speeds effectively. The auto throttle system works in conjunction with the FMS to automatically adjust engine thrust based on flight profile, ensuring that the aircraft maintains the desired speed during climb, cruise, and descent phases. This collaboration minimizes pilot workload and enhances fuel efficiency. Alternate operating conditions. In scenarios where the FMS may not function optimally, pilots can switch to alternate operating conditions. For instance, if the FMS fails or experiences a malfunction, pilots can revert to manual navigation methods using traditional flight instruments. Additionally, the auto throttle can disengage, requiring pilots to manually control thrust levels. This situation can increase pilot workload, especially during critical phases of flight, such as takeoffs and landings. Understanding how to operate the aircraft without these automated systems is crucial for maintaining safety and ensuring successful flight operations. Cockpit indications. The cockpit of the E170 is equipped with various displays that provide critical information related to the FMS and auto throttle. On the primary flight display, the PDF, pilots can see indications for flight paths, speed, and altitude. The malfunction display, MFD, may show route information and any alerted related to the MFS. Specific indications such as MSS fail or auto throttle disengage will alert the pilot to any issues that may arise. Understanding these indications is essential for effective decision making and maintaining situational awareness during the flight. Malfunctions and indications of malfunctions. Common malfunctions in the FMS can include loss of GPS signal, database errors, or system failures. Each of these issues will trigger specific alerts in the cockpit, such as warning lights or messages on the display. For instance, a GPS loss message would indicate that the FMS cannot determine the aircraft's position accurately, necessitating a shift to manual navigation. The auto throttle can also experience malfunctions, such as thrust discrepancies or failure to engage, which would be indicated by a warning message. Pilots must be trained to recognize these indications promptly to ensure safe flight operations. Other systems affected by malfunctions. A malfunction in the FMS or auto throttle can have cascading effects on other aircraft systems. For example, if the FMS is inoperative, navigation systems relying on its data may also become unreliable, impacting the autopilot and flight management tasks. Similarly, if the auto throttle fails, it can lead to manual thrust management, affecting engine performance and potentially resulting in speed deviations. Pilots need to be aware of these independencies to respond effectively to any issues that arise during the flight. Pilot considerations in troubleshooting. When faced with malfunctions in the FMS or autothrottle, pilots should follow established troubleshooting procedures. This includes referencing the aircraft's Quick Reference Handbook, the QRH, for specific guidance on addressing the issue. Pilots must prioritize safety by assuring the impact of the malfunction on the flight performance and making informed decisions about continuing the flight or executing an alternative plan. Effective communication with the flight crew and air traffic control is also essential during these situations to ensure that all parties are aware of the aircraft's status and any necessary deviations from the planned flight path. My works cited page. Thank you.